after minute. So I just want to go over a few of the questions. We're not going to have time to finish this. We're just getting started. We'll finish both of these activities next class. At least we'll go over them. I'd like you to work on them a little bit in between today and Monday. So the whole point of this is mostly talk about fractions, but we'll talk about shapes a little bit along the way. So when I cut the square in half along the main diagonal there, I end up with two shapes. What can you tell me about those two shapes?
They're equal.
They're equal. Okay, what else? In geometry, when two shapes are equal like that, we say they're congruent, which is okay. I mean, I'm just throwing out the vocabulary. And would you say they're? I
said symmetrical, but I guess
they are definitely symmetrical. Yeah, they're symmetrical around that cut line. Yep, that's cool too. And we're gonna have a lot of fun with geometry next term. So we'll come back to this activity next term, actually. What else can you tell me about them? Well, what I call shape A?
A triangle.
It's a triangle. Could you give it a better name than triangle?
Right triangle.
It's a right triangle. Excellent. That's better than just triangle. Can I give it a better name than right triangle? Think way back to geometry.
Isosceles.
Oh my gosh, you were on the roll today. Yeah, it's an isosceles. So the best name we could give it would be a right isosceles triangle. Describes all of its attributes. Triangle, three sides. Right, because we have that nice square angle in the upper left. And isosceles because it has two equal sides. Okay. Kind of cool. All right, so A is what fraction of the original square?
1/2.
1/2. Okay. The square is what fraction of A? What is it? 2 or
1/1.
2/1. Yeah, nice, cool. Okay. All right, so then we make another cut. We take A's partner over here and we cut it in half by drawing a line down. So I've got that over here. And so those are labeled 1 and 2. Make sure you label these suckers as we go because we're going to be comparing them to each other as we generate more shapes. Because ultimately we're going to break this figure into, I believe it's 7 shapes. And then we can try to put it back together. That's fun too. So what can you tell me about shapes 1 and 2?
They're congruent.
They are congruent to each other. Yes. What else?
They're equal halves.
They're equal halves of what?
One whole.
Of a whole. Okay. Yep. How do they compare to shape A?
They're half. Or one of them.
They are half. One of them is half of A. Yep. How else do they compare? Do they have the same shape or a different shape? They have the same shape. So
as A or each
as A, as triangle A. Yeah. So here's triangle A over here up in the upper left side. Down there. And here's 1 and 2. They actually have the same shape.
They're both 90 degrees.
They are both right isosceles triangles. They have the same shape. Not the same size, but they have the same shape. So we could put figure A on a copy machine, and we could say zoom it down to 50%, and we would get triangle 1. Or we could take triangle 1 and we say blow it up 200%, and we would get triangle A. It's kind of cool. All right, we get to do another cut. This one's a little tricky. In the next one, we have to make this line here. And to do that, the way that's recommended is if you fold this tip right here. Now, just some geometry lingo that we'll get into more next term. These points are also called vertices. And the pointier points are called acute vertices. Okay. So we would take the right angle vertex and we would fold it to the center of this side here. But first we have to find that center by folding the two acute points on top of each other. And then we can get the crease that's going to make the split. The nice thing about that crease right there, what do you think we did? What do you think we ended up doing to this side right here when we made that fold?
Cut it in half.
We did cut it in half. And to check that, what you could do is you could take figure 3 and you could move it down so that this vertex there sits right there. And you'll see the distance from here to there is the same as the distance from here to here. So we're going to use these pieces to help compare sizes to each other. And if we did our folds reasonably well, it should line up pretty good. And cups or tears, whichever route you're taking there. And then we're just about out of time, but I had time to make one more drawing here. It's way harder to draw these than it is to cut them. So the next thing we're going to do is we're going to take this acute vertex here and fold it over so it touches our center mark that we made before. And when we do that, we're going to get this crease right here, and we're going to chop that off as triangle 4. When we do that, we're left off with this figure, which I'm calling C. C is what kind of shape? Does anyone know what we would call C?
A parallelogram.
Almost. The parallelogram has to have 2 pairs of parallel sides, and this has 1 pair of parallel sides. So what shape has 1 pair of parallel sides?
Trapezoid?
A trapezoid. Yeah, it's a trapezoid. And back of shape here, B is also a trapezoid. Now B is kind of cooler than C, I think. Why?
And it's 3 of those triangles.
Ooh, 3 of what triangles?
The 3.
Oh, triangle 3, 3 of them make B. Did everyone come to that conclusion yet? Yeah, if you flip 3 over, do that in blue highlighter, then you get 1, 2, 3 of triangle 3 in there. Yeah.
But triangle 4 is half of triangle 3, so it makes
Triangle
3,
4 is
5,
half of triangle 3.
and you can fit 5 of them in rhombus C.
Okay, so let's see. Trapezoid. C.
Yeah, trapezoid.
Yeah, so okay, let me find, okay, you're getting way ahead of me here. So C, so you're saying 5 of triangle 4 fit inside trapezoid C.
So I think it's just as cool as the other one.
That's cool too. The reason I was thinking B was cool because it has, B is more symmetric than C, right? And the shape that B came from was an isosceles triangle, right? I just chopped the top off it. And when you do that, you get an isosceles trapezoid. It's kind of cool. So B is an isosceles trapezoid. Yeah. Okay, so we're just about out of time for fun with class today. So I'm going to stop here. So what I'd like you to try and do is if you hang out right now and finish cutting that sucker up if you didn't already. And then we'll go over those questions about this figure as part of that figure next class. So we'll tidy up any questions we need to answer in activities 1 and 2. So we're just warming up, just getting used to how to compare fractions, how you can play with them with homemade toys or store-bought toys. And so this is a homemade toy. The 7 shapes that result is part of a famous Japanese puzzle. I think it's Japanese. Could be Chinese. No, it's Chinese. No, I forgot. It's Chinese or it's Oriental. Let's go that way. Does anybody know what Oriental puzzle these 7 shapes make in the end? They're called tangrams. Have you heard of tangrams?
Oh yeah, I used to this all the time.
Yeah, so tangrams are a fun Japanese puzzle. So then the next challenge would be, can you take those 7 shapes and rebuild your original square? And then what other things can you build with these 7 shapes? We'll play around with that a little bit too. That's more geometry than fractions, but you know, we got it in front of us. We should play with it a little.
I didn't want to kind of back anyone back at home.
didn't know about it.
I didn't do it.
So
Oh,
these
no.
we're gonna work on like
Go. Cut all my shapes.
Yes. So homework is to try and finish up as much as possible in activities 1 and 2 that we played with today. And then on Monday, we will go over, make sure people got the same kind of answers, that we're all on the same page in the comparisons that we're going to do. And some of the questions in activity 2, I gave you 2 colors for a couple of reasons. One, in case you made a mistake, but it's also nice to cut out another set of these to help with those comparisons. Because a couple of different colors lined up make it easier to think about. And this is section 6.1 in the book that we're working on.